Okay, students. Now, what happens when you're trying to solve a system of equations through graphing? Well, really, graphing isn't that big of a deal because you already know how to graph. My suggestion though is to solve for y for each equation first before you graph. I mean, you could graph any way you want, but we're used to solving for y so many times that it's just easier for us to do that now. Something we're more used to. So here, if I subtract 5x on both sides, this 5x will cancel and I'll only be left with negative 4y. And if I subtract 5x on the other side of my equation, I'll be left with 10 minus 5y. If I 5x, sorry. If I divide by 4 on all my terms, negative 4 divided by y would just be y. Negative 4 divided by 10 would be 10 divided by 4. And negative 4 divided by negative 5 would be 5 over 4x. And that's my first equation. Now my second equation says 15x plus 4y equals 190. A lot of the problems in your textbook, the numbers are a lot smaller than this, but it's a good example. If I subtract 15x on both sides of my equation, negative 15x plus 15x is nothing, so I'll be left with 4y. And if I subtract 15x on the other side of my equation, I'd be left with 190 minus 15x. Now, if I divide by 4 on all my terms, 4 divided by 4 is just 1, and I'll be left with y. And 4 divided by 190, well, is 190 over 4. And negative 15x divided by 4 is just negative 15 divided by 4. I don't need that negative because I already have it in front. X. Now that I have that, let's use my graphing program. And I can just graph both of these. Now, unfortunately, you don't have your own graphing program, and that's okay. Okay, now I'll just have to add my own equation, so let's see. I need my equation palette. So my first equation, y was equal to 10 over 4 plus, where's my next equation? 5 over 4 x. And I need a second equation. And my next equation, I have y is equal to 190 over 4 minus 15 over 4 x. So you know what? I made a small mistake. Because negative 4 divided by 10 should have been negative 10 over 4. So let's fix that in my equation. There we go. So, when I look at both equations, they both have an intersection point. And if I look at my intersection point a little bit closer here, I notice that I'm moving 10 spaces to my right. I'm counting by twos here. 2, 4, 6, 8, 10. And I'm moving 10 spaces up. This time I'm counting by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So where is the point where these two lines actually meet? Well, the point where these two lines actually meet will be 10, 10. And that's again where the point where my two lines are actually meeting. And my intersection point when I graph two lines is my answer. I hope this helps.